Today we will be starting with a new chapter, optics. So, you would already have an idea about this particular topic. You would have studied in your lower classes, 8th, 9th, 10th. So, we will be discussing those concepts once again, and we will be learning a bit more. So, let us start off. So, optics, you basically know that it is the study of light. So, generally the WIBGR range of the spectrum, the electromagnetic spectrum will be studying about the visible light basically. So, in this particular chapter we basically segregate it into two types. One is called geometrical optics and the other one is wave optics. So, today we will be starting off with geometrical optics. So, what is the basic difference between these two is the way we analyze the light. So, in some cases we will be using geometrical optics to analyze light, and in some cases wave optics would be more appropriate. So, let us see which method would be better to use. So, whenever we have light which is interacting with bodies or devices which are having a sizes larger than the wavelength of light, far larger than the wavelength of light. So, in such cases geometrical optics would be the way we use to analyze light. So, I will just write it down here. When light interacts with objects or devices whose sizes are far greater than the wavelength of light. So, in such a scenario we will be understanding the properties of light by using geometrical optics. So, for example, whenever we are dealing with mirrors or lens or telescopes, so something like this. So, all these objects which I have written here, they are having far larger size when compared to the wavelength of light. So, when I am talking about visible light, you all know that its wavelength lies from 4000 to 7000 angstroms, which is a very small value when compared to the sizes of these objects. And in the same manner we can talk about wave optics. So, wave optics is the method we use to analyze some different properties of light like interference and polarization. So, these are some properties which can be explained only by using wave optics. Now, apart from that, one major thing here is that in such an analysis we can say that the sizes of the equipment which we are using, the devices, the experimental apparatus, so that would be comparable. So, sizes are comparable to wavelength of light. So, that is the basic difference between how we analyze light. Okay. So, today we will be starting off with geometrical optics, which is also called as ray optics. And the reason why it is called ray optics is because throughout this particular topic we will be understanding the behavior of light by drawing rays. So, a ray is something which we use to represent the path in which the light is travelling. So, we will discuss that in a while. And as the name suggests, geometrical optics, it involves a lot of geometry also to understand how light interacts and how light forms images. So, we will be using all basic geometry. So, by basic I mean very basic, which you would be learning in 8th, 9th, 10th classes. That part of geometry would be enough for us. Okay. So, now let us first talk about one important property of light, which we call as rectilinear propagation. So, rectilinear propagation basically means that light always travels in straight lines from one point to another point. So, whenever we consider a medium which is homogeneous, which is isotropic, so in such a medium we can say that there is no bending of light that is going to happen. So, there are cases where light can bend as well, whenever the medium is changing its properties, which we will discuss in the later part of the chapter. But whenever we have a uniform medium, for example, let us say this room is uniformly filled with air and the temperature is same, pressure is same. So, when all the parameters are similar at each and every part of the medium, and in such a medium whenever a light ray is travelling, then it has to travel from one point to another point in a straight line. So, that is what we mean by rectilinear propagation. So, I can write that here: light travels between 2 points in a straight line, and as I told you, whatever I have written is in a homogeneous medium. So, we can understand this by a very simple experimental apparatus, which I will draw out over here. So, let us say there is a cardboard like this, which is an opaque substance, opaque object, and it has a hole. Let us consider a small hole, and here we use a light, some sort of torch or something like that, and it is emitting light. So, it is emitting light in all directions. So, when this light goes and strikes the cardboard box with a hole in it, you know that the cardboard will basically block the light rays from moving to the other side, because it is an opaque object. Now, if let us say there is a screen on the other side, so here we have a screen. So, now what would you see on the screen? So, you can easily expect, you all would have experienced this also, you would see that the light which is coming from the torch would travel in this way, and it would form a spot, a bright spot on the screen, and it would be like this, which would have the similar shape of the hole. So, the only thing is that it would have slightly enlarged because of the distance and because of the diverging nature of this light. Okay. So, now you can easily expect that there are different parts of the screen where there is no light. So, we can say that there is no light here, and there is no light in this part of the case also. Only here we have a bright spot which is formed, because there is a direct path from the source to this point without any obstruction. So, light is just travelling in a straight line from here to there, and that straight line concept can also be understood by looking at the shape. So, only because it is a straight line, we are getting the spot here also to be the same shape as that of the hole which is present here. Now, you can easily understand the reason why light is not reaching this point is because when light tries to travel from here to here in a straight line like this, so the opaque object in between, it is basically blocking the passage of light. So, there is no way the light can travel around the block, I mean this opaque object like this, and reach this point. So, that is the reason why we have a dark region which is formed over here. So, this is a very simple example to understand the rectilinear propagation of light. So, rectilinear means straight line, basically rectilinear motion. So, that is the idea. And throughout this chapter we will be understanding all properties or behavior of light, object, image formation. All this will be understood by using the concept of rays, so which I have earlier mentioned, or ray. So, a ray is basically something, a straight line which we use to represent the path followed by light. So, I will just write it down. The path followed by light is called a ray, and we will just represent that with a straight line. We will also use an arrow mark to represent the direction in which the light is travelling. So, I can write it like this. So, that represents the path followed by light, and sometimes we will be using this term called beam of light, we will be calling it as. So, a beam of light is nothing but a group of many rays. So, large number of rays moving together is what we call as a beam. So, we can say that here as the torch emits light, so it basically emits a beam of light, because there are many light rays which are originating from the source. So, that collection of all those rays or that bundle of rays is what we call as a beam. So, we can say that beam is basically a bundle of many rays. So, we can understand that it is something like this. So, that collection of many rays is what we call as a beam. And one more important thing which we you have to know here is that whenever I have a source, and from that source, if you need to look at how many light rays are coming out. So, what would be the answer? How many light rays how many light rays will come out of a source? Is it 1, 2, 3, 10, 100? The answer for that would be infinity. So, like I told you, ray is just an idea which we have created, that light can be divided into a very thin beam, and that is what we called as a ray. So, ideally speaking, when I consider the light coming from the source, we can actually say that there are infinite number of light rays which are coming out of it. So, a ray is just a concept which we are using to understand the behavior of light. So, keep in mind that every source, however small the source is, the light coming from it will have infinite rays coming out of it. But to analyze the behavior of light, we do not need infinite rays, we can't draw infinite rays. So, you will understand in a while that there, even if we draw 2 light rays, that is enough for us to understand the effects that the light creates. So, we will see why 2 light rays are required in a while. Throughout this chapter, we will be using these terms called object and image. So, let us try to understand what they mean. So, we will see what an object is first. Okay. So, we define it like this. So, anything from which light comes out is basically an object. So, for example, if I am trying to see something, so the reason why I am able to see something is because light rays are coming from that and reaching my eye, and my eye, the inside part, is receiving that light and it is transmitting signals to my brain, which is able to comprehend it. So, basically to see something, we need some light coming out of it. So, anything from which light comes out is what we call as an object. So, object is basically, we can understand it like this, it is a source of light. So, you can say that light should come out of that particular body. It need not be a producer of light, it might not create light from itself, like let us say a light bulb. Light bulb produces light. So, object is not something which produces light. Something which produces light can also be called as an object, but the general definition is that light should come out of it. It can come in many ways. One is that it may produce light, and the most common scenario is that it may reflect light. It could also be a reflector of light. And most objects which we see in our daily life are because of this property, because they are all reflectors of light. Otherwise, we would not be able to see them. So, think of it, when you just go out on daytime. So, most of the things which you see outside, you are not seeing them because they are sending light or they are producing light on their own. They are just reflecting the light which is falling onto them from the sun, and that is the reason why you are able to see them. And if you go outside at night, the same objects you will not be able to see. The reason is because they are not producing light, they are not even reflecting light. So, that is the basic idea. So, anything that is sending out light is basically an object. Okay. Now, when we talk about object in the ray optics point of view, we have a slightly different definition which we will see now. So, we define it like this: the point of intersection of incident rays is called an object. So, a very simple definition. So, whenever I have many light rays coming onto my eye, let us say, so if many light rays are coming and striking my eye, all I have to do is take those light rays and find out where all those light rays are converging, or where all those lines are intersecting. So, that point of intersection of all the light rays which are reaching a particular device is what we call as an object. That is the position of the object. And That is exactly how even our human eye works. So, I guess you might have had an idea, you would have studied briefly about this in your lower classes also. So, for example, let us say we have, this is the eye. So, let us say one light ray is coming like this and the other light ray is coming like this. Now, when this person who is receiving these two light rays, so our eye or any other device only has the ability to understand or analyze what it is receiving. So, in this particular case, the eye is just able to analyze the information which this light ray is giving it using its direction. So, what eye thinks here is that because light ray is coming in this direction, it has this ability to understand that this light ray should have originated at some point over here or at some point over here or over here, and it will just extend this light ray further backwards, and it thinks that it could have originated at any point on this line behind. So, that idea every device would have, because everything knows that light travels in a straight line. So, it is something like that. Now, if you are receiving one more light ray which is in a different direction like this, we can use the same concept once again. This light ray might have originated over here, or we can extend this backwards and we can say that it could have originated at any point on this line in this manner. Now, understanding logically, so this light ray, it would have originated at any point on this line, this light ray could have originated at any point on this line, and because both the light rays are coming from the same object, the only possible conclusion we can make is that that object should be at the point of intersection of those two light rays. So, you can see the definition which I have written here. The object, the point of intersection of the incident rays is called the object. Now, according to this person, these two light rays are coming in this direction. So, these are the incident rays according to this person. And how does he locate the object? The way he is locating the object is by tracing these two light rays backwards and estimating where it is intersecting. And the point where it is intersecting is the point from where those two light rays have originated, which means this is the point from which the two light rays have started traveling towards the person. So, this is what we call as the object. And as you can see here, to be able to find the intersection point, I need at least two rays. One ray would not be sufficient. So, that is the reason throughout this chapter, whenever we are analyzing the behavior of light, we will be requiring at least two light rays to make out that intersection point where the intersection happens. And similarly, now let us talk about image. So, we will understand the concept of image also by using a similar type of example. So, let us consider that this person is once again receiving two light rays in the same manner as earlier. So, the two light rays are all exactly similar to the earlier light rays. So, they were like this. Now, once again he does the same analysis like earlier. The two light rays, he knows that we have to trace them back to find the point of intersection, because that is how light behaves. Now, it might be possible that these two light rays, instead of starting from some point over here and diverging in this manner and reaching the person like the earlier case, it might be possible that there is some device in between, there is some sort of device over here, a mirror. Basically, let us consider that there is a mirror, and these two light rays are coming from a different direction, but after reflection from the mirror, they could have traveled in this final direction. So, let me show that over here. So, let us say the light rays are starting from some point over here, let us say something over here, and so in this case the light rays would have initially started from this particular point. They would have traveled in this direction, and after striking with the mirror, they would have reflected in this direction, and they are moving in the exact same manner as the earlier case. So, something like that is also possible. Now, this person would not be able to differentiate, because he is only analyzing the last part of the light ray which he is receiving, and he is just tracing them backwards. What he did here was also not see everything what is happening over here. He just took the final two rays looked at that direction and then traced them back to find the origin or the intersection point. Now, when he does the same thing with this also, he thinks that the light rays are coming from somewhere on this line. He also thinks that the light rays are coming from some point on this line, and when he finds the intersection point by tracing them backwards, he would once again observe that the object is somewhere over here. So, he thinks once again that this is the origin or this is the point from where these two light rays are originating. So, what happened in this particular scenario is that because of the presence of mirror, this mirror is making this person believe that the light rays are coming from here when the light rays are actually starting from here, which means this person's perception has changed because of the presence of this particular mirror. So, this mirror is making him believe that the light rays are actually coming from here. So, that is the basic idea. So, in such a scenario, we will be defining an object and an image. So, understand this definition carefully here. So, if you see here, this is the point from which the light rays are originating and striking the mirror, and these are the incident rays. So, when these incident rays are striking the mirror, these are the reflected rays which the person is actually receiving. So, in such a scenario, we define that this is the object for the mirror, and because it is taking the light rays from the object and changing them into a different direction, making everyone believe that these two light rays are coming from here. So, what this mirror has done is that it has changed the location of the object from this position to this position. We can say that this is the image of object in the mirror. So, whenever we are defining an object and an image, so we also have to define for whom. Without that for whom, it does not make any sense. Something which is an object for me is an image for something else. Let me just give you a very simple example. For this person, this one here is an object because he thinks that the light rays are actually coming from here. So, for this person, this is an object, like I told you earlier. So, these are the incident rays for the person, but these are the reflected rays for the mirror. So, keep in mind, whenever we are defining an object or an image, we need to define with respect to whom. So, this mirror is taking the light rays from the object and converting them into light rays as if they are coming from over here. So, that is the basic idea. So, this mirror has changed the properties of this into this. So, that is what the mirror is doing here. So, we can define an image like this. It is the perception of where the light rays appear to come from. So, that is the basic idea of how we understand an image. So, just like we have defined in the case of an object for in terms of the incident rays, we can also define a similar statement for an image as well. So, we can write it like this: it is the point of intersection of the rays reflected or refracted from a device. So, you will understand what refraction means earlier. Some of you might have already studied about it as well. So, we do that in case of lens and devices like that. So, for now let us understand the reflected part. So, whenever light strikes a mirror and it gets reflected from a mirror, when you look at the light rays reflected, and if you just trace them to make them converge. The point where they converge, where they intersect, is what we call as the location of image. So, that is the basic idea. So, remember that object is located by using the incident rays, image is located by using the reflected rays, or in the next coming cases refracted rays. So, based on these intersection, we will be defining them as real image and virtual image. So, real image is something which is basically formed by actual intersection of reflected rays. If you see this particular scenario which I have drawn, so the reflected rays in this case are not actually intersecting over here. I had to trace them backwards and make them intersect at this particular point. So, this kind of an image formed is called as a virtual image, because this is not the actual intersection point of the reflected rays. So, these are the reflected rays. So, reflected light rays are actually diverging in this scenario. So, if I have to make them intersect, I will just have to go behind the mirror, I will have to trace them back behind the mirror and make them intersect. So, such kind of image formed is what we call as a virtual image. So, there is nothing actually present there, it appears like something is there and light is coming from over there. So, that kind of an image is called as a virtual image. So, virtual image, let me write it down over here. Real image is formed by actual intersection of reflected rays. And when it comes to virtual image, we can write a similar expression. So, actual rays do not intersect, we have to trace them backwards, we have to trace them and find the point of intersection. So, that point of intersection which is formed by tracing out light rays to region where there are actually no rays. So, that intersection point which is created with not real rays, there is nothing over here, we have just drawn some lines to locate this particular point. That is the perception of us as to where the light rays are coming from. So, to locate that perception which we have, to understand that particular location, we are just drawing some lines which are not actually light rays to locate that, and that position is what we call as the virtual image. So, that is the basic idea. We can also write one more point about this real image and virtual image. So, we can say that real image, it can be caught on a screen, and the reason why it is caught on a screen is because if actual light rays are intersecting to form a real image, if a screen is placed over there, the two light rays fall onto that screen and they create some light over there, so which can be seen once again. Now, a virtual image is something which cannot be caught on a screen. So, just think of a scenario, although this person thinks that the light rays are coming from a point which is over here, if I place something over here behind the mirror, will something be formed on that mirror? No, because there is nothing which is going and falling on the mirror. So, this is just a perception that light rays are coming from over here. So, that is the reason why we say that a virtual image cannot be caught on a screen. So, that is the basic idea about object and image. So, remember that object is associated with the incident rays and the point of intersection of the incident rays, whereas image is associated with the reflected rays in this scenario, later on refracted rays also, and the point of intersection of those rays. And depending on whether actual light rays are meeting or they are appearing to meet with each other, we define that image either as a real image or a virtual image. Now, we will discuss about reflection. So, we can understand reflection by using two basic laws. So, laws of reflection. So, you would have studied this, these are very basic concepts which you would have studied in your lower classes as well. So, we will just go through them quickly once again. So, the first law, so whenever we have a surface onto which a light ray is incident, and if I consider that the light ray is striking at this point, let us call it as O. So, we define, if I draw a perpendicular to that surface at that particular point, so we call that as the normal, and this light ray I will call it as the incident ray. So, once it gets reflected from this surface, so we can say that if the light ray is travelling in this direction, so let us call it as the reflected ray. So, this angle which we take here between the incident ray and the normal, so I will write it as I and this angle as R, angle of incidence and angle of reflection. So, remember that the angles of incidence and reflection are measured with respect to the normal, angles with normal. So, this is something which you will have to keep in mind. Okay. So, first law states that the angle of incidence is equal to the angle of reflection. A very simple law you can say. So, whatever is the angle at which the incident ray makes or strikes with the normal. So, whatever is the angle that the incident ray makes with the normal while striking the surface, the reflected ray also reflects back at the same angle with the normal. So, that is the basic idea, and similarly you can write second law. So, it states that the incident ray, the reflected ray and the normal, the incident ray, reflected ray and normal lie in the same plane. So, this is something which you will have to keep in mind. So, what this means is that this line which I have drawn, incident ray, reflected ray and the normal, they all the three should lie in the same plane. So, like in the plane of the board, as you can see. So, all the three here are in the same plane, which is the board. Now, it means that if incident ray, let us say, is in the board plane, normal is in the board plane, it means reflected ray can never be outside the board plane, something like this. So, if one light ray comes in this direction, the other light ray cannot reflect in this direction, even though it makes the same angle. So, that is not how it works. All the three should lie in the same plane. So, that is a basic idea. So, I will just represent it like this over here. So, if you consider that this is the plane which I am drawing, which is in the plane of the board. So, all the three should lie in that plane. So, that is the basic idea. So, to represent this mathematically, I will be using this. So, if I consider EI cap as the unit vector along incident ray. So, this is the unit vector along the incident ray, and if I use ER cap as the unit vector along the reflected ray, and let us say N cap is along normal. So, this is the normal direction. N cap direction is like that. EI cap is in this direction having a magnitude of 1, ER cap is in this direction also having a magnitude of 1. So, to represent the same thing which I have written here, that all the three should lie in a same plane, mathematically I can write it like this: EI cap cross N cap is equal to ER cap cross N cap. So, this is a way of representing that. So, all those three vectors should lie in the same plane. So, that is the basic idea. Now, one important thing which you will have to keep in mind here is that whenever reflection occurs, so what is that which is changing? So, let's see that now here. So, if I consider the same scenario, so this is the normal, and let us say I am considering the unit vector of the incident ray. So, if I consider that this is the unit vector of the incident ray, which is having a magnitude of 1, so EI cap basically. So, you know that the reflected ray also has the same angle. If this is theta, this is also theta, and this will also have a magnitude of 1 if I consider this also as the unit vector. So, what I am going to do now is I am going to resolve this vector into two components. So, if you see, so if I consider that this is the surface and this is the normal. So, what I will do is I will resolve this into two components, one in this direction and one in this direction. So, this is one vector and this is the other vector. Similarly, if I resolve the reflected ray also into two components, one is this vector and the other one would be this vector. Now, if you see here, what I will do is I will call this as EI parallel, and I will call this one as EI perpendicular to the surface. Now, if you see, I can write EI cap as EI parallel plus EI perpendicular. So, I can represent it like this, yes. So, just this vector plus this vector is equal to this vector. Now, if I try to write the reflected ray also in the similar manner, you can easily see that because the angles are basically same, this angle is equal to this angle will automatically mean this and this are also same, this and this are 90 degrees and this have a magnitude of 1. So, they are basically congruent triangles, this right angle triangle and this right angle triangle. So, I can say this vector and this vector will be the same. So, I can write this reflected ray as EI parallel cap, which is the same as this vector, both are one and the same. Now, when you look at this vector, you can say that the incident ray has a component in this direction and the reflected ray has a similar magnitude in the opposite direction. So, to represent this vector, I can write it as minus of this vector. So, this is minus of EI perpendicular cap. So, minus EI perpendicular cap. So, this is the basic idea. So, what you will have to understand from here is that whenever a light ray strikes a particular surface, the component of that direction or the component of that vector in the plane of the mirror. So, this parallel component basically means the plane of the mirror. So, the component which is in the plane of the mirror is not going to change, whereas the component which is perpendicular to the mirror is the one which is going to get reversed. So, that is the basic idea. So, I will just give you a small example based on this. Let us consider a simple case. Let us say that there is a incident ray which is having a unit vector which is given by, let us say, I cap plus j cap or 2I cap plus j cap by root 5. So, let us consider that the unit vector is like this. Now, if this light ray is incident on a mirror and that mirror is placed in xz plane. So, the mirror is in the xz plane. X means this, if you consider this as x, this as y. So, z will be outwards. So, xz plane basically means this. So, this is x and this is z. So, this is xz plane. So, the mirror is basically like this and this is the incident light ray. So, if this incident light ray strikes a mirror which is like this, you need to find out what is the unit vector in the direction of reflected ray. What is ER cap? Now, according to the idea which we discussed just now, whenever any light ray strikes a mirror, the component of that light ray or the component of that vector in the plane of the mirror is not going to change. The only component which is perpendicular to the mirror, which is along the normal to the mirror, will get reversed. So, keeping that in mind, I will just try to understand this in that way. So, when you look at 2I cap by root 5, so this I can understand this as 2I cap by root 5 plus j cap by root 5. Now, out of these two, which one is in the plane of the mirror, which one is perpendicular to the plane of the mirror? Our mirror is in the xz plane. So, which means for xz plane, which is this horizontal plane, y axis will be the normal. So, this will be the normal direction. which means all the I cap and k cap components, if they are present, will be in the plane of the mirror. So, I do not have to change any of the I cap and k cap components because they are in the plane of the mirror, but I will have to reverse the j cap component because that is along the normal. So, that is what we have discussed here. The parallel component will remain the same in direction as well, whereas the perpendicular component will get reversed. So, I can directly write the unit vector in the direction of reflected ray as 2 I cap by root 5. This is the parallel component. So, I am just writing it in the same way without changing its sign, whereas this one I will have to change the sign because that is the normal direction. So, that would be the unit vector in the direction of reflected ray. Now, let us start with the plane mirror. So, you all know that plane mirror basically has two surfaces, one of which is the silvered surface and the other one would be the polished surface. The polished surface is the reflecting surface basically. So, when I consider this as the plane mirror, so we basically draw a dashed lines on the one side which represents the silvered side. So, silvering basically means coating that mirror on one or that glass slab. We just take a thin glass slab and on one side we coat it with a silver surface, metallic silver would be coated on one side because it is a good reflector. So, mirror should be a good reflector of light. So, we silver that on one side and the other side would be polished. So, that is what we mean. So, this side will be the polished side which is also the reflecting side. So, this is the reflecting side. Okay. So, now let us consider the image formation in the case of a plane mirror. So, I will take a point object first and then we will move on to larger objects as well. So, if I consider that there is an object over here placed at some distance. So, we have already understood earlier that whenever we need to understand the location of the image formed by a mirror or any other device, we need at least two rays. We need to trace those two rays onto the mirror, we need to send those two rays onto the mirror, reflect them back and look at where the reflected rays are coming from. How do we perceive the reflected rays to come from or where do they appear to come from? So, that is how we understand it. So, I will draw two light rays, one light ray I will consider it like this, one light ray I will consider it like this, and I guess you are all aware of what this light ray represents. So, that is moving in the direction normal to the mirror. When a light ray moves normal to the mirror, what is the angle of incidence? Is it 90? It is not 90, it is 0. So, don't get confused by looking at this angle. So, we will have to measure the angle with the normal. So, the normal will be like this and the light ray is also travelling in the same direction. So, the angle of incidence in the case of normal incidence is 0. Okay. Now, let us draw the light rays after reflection. You know that this light ray, because it is incident normally, should also get reflected normally backwards. So, the angle of reflection should also be 0. So, it just comes along the same line. Now, this light ray, to find out where this light ray travels, I will just draw the normal at this point. So, this is the normal and making sure that this angle is same as the reflecting angle, the angle of reflection, I will draw the reflected light ray. So, it would be something like this. So, once we draw the reflected light ray, so I have two light rays now. So, one light ray is coming in this direction after reflection from here, another light ray is coming from this direction. Now, so this is where the object is. I have told you earlier, because this is the point from where the incident rays appear to come from, or they are actually coming from that particular point. So, these are the incident rays and incident rays are converging at this particular point. So, that is the object. Now, so this and this are the reflected rays. Now, our idea is to understand whether or not we can find the intersection point. These two light rays, if you see, you can clearly observe that they are diverging, and diverging light rays do not intersect anywhere on this side. So, we are now very clear that these two light rays do not intersect on their own. So, it cannot form a real image. So, the only thing that they can do is appear to converge on the other side. I will remove this for a while. Okay, so these two light rays when traced backwards, so they appear to come from a point which is behind. So, if I draw, I am just tracing this light ray backwards, and similarly I am tracing this light ray also backwards. So, both of them appear to come from a point which is over here, and that point is what we call as the image of this object formed by the mirror. So, that is the basic idea. Now, let us try to locate where the image is formed. So, if you look at these two triangles which I have drawn, which we got here, let me name them. This is O, let us call this as A, B, and that is I. So, look at the triangles OAB and ABI. So, you can see that one side is common for both, and we know that if this angle is I, this angle R is also equal to I, right. And if this angle is I, because this line and this line are parallel, we can say that this angle is also I. And similarly, this angle here is R, this line and this line are parallel, and this is the same line. So, I can say this will also be equal to R, which is once again equal to I. So, what that means is this angle and this angle are equal to each other. So, if you see these two triangles, one side is common, this and this are equal, and the other two angles in both are 90 degrees. So, which means from ASA property we can say that or RHS you can say that. So, from ASA property we can say that these two triangles are congruent to each other. So, they are same, they are of the same size. So, in this particular case we can say that this distance OA is equal to this distance BI. So, this OA is called as the object distance, generally represented with a U, and this one here is the image distance, which is generally represented with the symbol V. So, that is the basic idea. Now, remember that whenever you need to find out the location of an image for the object, the actual method is to do the ray diagram, take at least two rays and draw them backwards, draw them and project them backwards and find the intersection point. But now that we have already established that, so in all the further analysis, we can use a very simple method to understand the location of the image. You can observe that in this diagram as well. So, we know that if this is the object, the image would be formed over here at exactly the same distance from the object. And what you can do is, if you see the line which is joining the object and the image, so that line is actually perpendicular to the mirror. Now, this is a very important observation which you will have to make, and it makes many analysis very simpler also. So, instead of drawing ray diagrams each and every time, I can just make use of these two. One is that the line joining the object and the image should be perpendicular to each other, and the object and image are equidistant from the mirror, from the plane of the mirror. So, I will just write it down here, which this is already written. So, line joining object and image is perpendicular to the plane of the mirror. Using the same logic which we discussed, let us see an example now. So, let us consider that there is a mirror over here which is placed in this manner, and there is an object which is at this position, let us say. So, the mirror is placed in this way. So, let us consider that this object is at a distance of 5 meters. This is the origin. So, it is on the x axis at a distance of 5 meters. So, the image is formed in this mirror for this particular object. You know that it will be behind the mirror, because it is a virtual image, it is formed behind the mirror. So, it is formed somewhere over here. So, considering that this is the x axis and this is the y axis. So, we will now try to find out the location of the image and the coordinates of the image. So, one way of doing that is drawing the ray diagram once again, just like the earlier scenario, finding the point of intersection. So, which would be pretty lengthy in this scenario. So, what I will do is I will just use the basic two concepts which we have discussed at the end. One is that the distance from the mirror, the perpendicular distance of object and image from the plane of the mirror should be equal, that is one thing. And the second one is that the line joining the object and the image should be perpendicular to the mirror. So, what I will do is I will draw a line from the object to the mirror which is perpendicular, and I will find its length, and I will extend that onto the other side by the same distance. Okay, to find this length we need the angle over here. So, let us consider that this angle is some 30 degrees. So, that angle is 30 degrees. So, we need to basically find out the location or the coordinates of this particular point, which will be the image. So, this would be the image. Okay. So, now what I will do is I will draw one more line from here just for understanding. So, if I draw one more line, here you can say that this length and this length will be equal to each other, and this line is the common side for the two triangles which are formed over here. So, if you consider this right angle triangle and this right angle triangle, so this side is common and this length is also common, we have just established that. So, which means these two are congruent triangles, right. So, 90 90, same length and same side for both the triangles. So, these two are congruent. So, what I can say in this particular scenario is that because this angle is 30 degrees, this angle here is also 30 degrees. So, this will also be 30 degrees. So, if this is where the image is formed, I now know that image is formed once again because these two are congruent triangles. If this is 5 meters, this length will also be 5 meters. So, that image is formed at a distance of 5 meters from the origin on a line making an angle of 60 degrees. I will just represent that over here. So, if this is the line making an angle of 60 degrees, so the image is formed over here at a distance of 5 meters and this is 60 degrees. So, now you can easily find the coordinates of that. So, this will be the x coordinate and this length will be the y coordinate. So, the image is basically formed at 5 cos 60 comma y coordinate is 5 sin 60. So, which is 5 by 2 comma 5 root 3 by 2. So, that would be the coordinates of the image. So, this is a very simple way of analyzing image formed with a plane mirror. So, always make sure that you take a point, the object, and draw a perpendicular onto the mirror, extend by the same distance behind the mirror, and that would be the location of image. Now, let us try to find out the image formed by a plane mirror for an extended object. So, if I consider that the object is like this, having some length placed in front of the mirror. So, how do we draw the image of that? So, in such a case what we can do is this extended object can be considered as a collection of many point objects. So, we can consider it as many point objects which are present, and we can find the location of those point images. And instead of that, what I can do is, instead of considering a large number, I can just take the extreme ends of that extended object, take them as 2 point objects and locate the images of these two extreme ends. So, not just in this scenario, we will be discussing the similar ideas for every other case later with lens, with mirrors, spherical mirrors. So, everywhere whenever dealing with an extended object, make sure that you consider it as 2 point objects at the two ends of that extended object, locate the images of the two ends and just join them. So, that would be the image location or the final image which is formed. So, let me call this as A and this as B. Now, let us find out where the image is formed. So, we have just discussed one way of doing that is by taking a light ray from this, reflecting it back, taking one more light ray from here, reflecting it back, and finding the point of intersection of the reflected rays behind the mirror. So, that is one way of doing it, but we can't keep doing drawing the ray diagram each and every time. So, we discussed one more way, which is draw a perpendicular from the point object onto the mirror, draw the same amount of length on the other side perpendicular to the mirror, and that is where the image is formed. So, this is where B dash is formed and this is where A dash is formed. So, you can directly say that this is how the image is formed. Now, there are few properties which we will have to know when it comes to an extended object. So, which you can clearly see in the diagram itself. So, we can directly say that once again the object distance and the image distance will be equal to each other. If this is d, that will also be d, and if the object height is HO, we can say that the image height is also the same. So, HO is equal to HI, and similarly you can say object distance and image distance will be equal to each other. So, these are some properties when it comes to the extended object in the case of a plane mirror. Okay. So, I want you to do this, take this and try to draw the image of this in the case of a plane mirror. So, if this is A, B, C, how would the image of this be? So, do this, and if you see the answer, I have told you just now, whenever we have extended objects, just take few points, try to locate the image of those and understand it. So, in this case I will just directly look at how much perpendicular distance A is present from the mirror, draw the same amount of distance behind. So, I should make sure that this length and this length are equal. I will do the same thing with B. So, I will find the distance of B and same distance I will draw behind the mirror. So, this is where B dash is formed, this is where A dash is formed, and now similarly I will do for C dash as well. So, I will find this distance and I will draw the same distance on the other side. So, this is where C dash is formed. So, now I will just join these 3 points. And so, this is how the image would be formed.